RedPajama, and I will bring Vipul to the stage. Hello, how's it going?
Hi, it's going
Did
well.
you do any dancing on your end?
Oh no, I was quite inspired
Yeah,
by Prometheus, so
I
I'm gonna
mean,
try that after the talk.
he's quite talented, and I think you could see that he is a father of two with the unicorn and the bassinet in the background. So
Right.
he's doing it all. Well, here are the slides. Really pumped to hear about building RedPajama. Thanks so much.
Yeah. Thanks for having me. Good afternoon, everyone. Vipul Prakash, co-founder CEO of Together, and we are focused on making AI more accessible and efficient. And today we'll be talking about building RedPajama and open source LLMs. So we've seen this amazing progress in machine learning and AI over the last few years. We have these incredible models like Stable Diffusion and OpenAI's GPT that can generate coherent images and text, and it really feels like a step function has happened. But there's really been continuous progress in the field, and we have principled ways of measuring this progress with benchmarks. So if you look at the ImageNet benchmark, we've achieved 30 points of accuracy in the last decade. If you look at the Squad benchmark, which is an NLP benchmark, we have achieved 25 points of accuracy in the last 7 years. And this is pretty incredible. We are hitting high 90s in accuracy on these systems, and they're opening up a lot of applications for AI. And we have reasons to believe that this is a trend that is going to continue for a long time to come. And what's behind this? There are a lot of factors, from research to experimentation, to capital that has gone into AI. But really, the two driving forces behind progress in AI can be boiled down to data and compute. And there's a couple of ways of thinking about the scale in this. One of them is OpenAI's scaling laws, which were published in a paper a couple of years ago, which showed that as the data size gets bigger, the model gets better. There's almost a linear relationship here. And the counterpart of this on the right is the compute graph, which shows, as we are pumping more data through the training framework of these models, we need more compute, and we are now using prodigious amounts of compute to train these models. But this is not wasted compute. Really, every flop is producing some proportional gain in quality of the models, and this reflects in the data sets that we've had and the sizes of those. If you look at the largest data set we had 10 years ago, which was available to the community in the open, was the ImageNet data set with 1.3 million images. And today, image models are trained on 3 billion images or more. This is 3 orders of magnitude increase. And the counterpart on the compute side, to train a model like GPT-3, you need 1,800 GPUs running continuously for a month. And this is not even the most expensive model that you can train today. So it's really the combination of scale in data and scale in compute that is giving us the amazing AI models we have today. And this is the reason we think that this will continue to happen. From a practitioner and researcher's perspective, this sort of manifests as a tension between three things. And again, this has been the case for the last decade, and likely will be the case for the next decade. One of the components is data. As the data volume and complexity goes up, invariably the data quality drops, and the cost of cleaning and acquiring this data goes up. And to sort of contend with higher volume and higher complexity data, we need models that are bigger and more complex. And both of these things then put pressure on the infrastructure side, where we need more flops to train these models, and more memory to hold them for inference. This has led to, as we've seen, specialization in GPU hardware. We have systolic arrays and tensor cores that improve the speed of matrix multiplications by 4 times. And just as importantly, scale out, which is using many GPUs in a distributed setting and doing that effectively. And it's, kind of the, in this sort of setup is where the Llama moment has happened. If you look at the Llama paper, they used 1 trillion tokens from a diverse set of data to train the Llama model. It used tens of thousands of GPU hours to do this, and produced this really sort of high quality model that we have. And we were inspired by this, partly. If you look at the data set, this is an open data set. This is not just available to one of the largest companies in the world. This is available to everyone. It's available to everyone here. And our objective with RedPajama is to see if we can create a fully reproducible open model with Llama quality, and more importantly, go beyond this quality. And when we talk about open models, open weights are obviously important, but we think this openness on these 4 dimensions that's critical for sort of monotonic progress in the quality of open models. We need open weights so they can be used anywhere. They can be fine-tuned. They can be used in fully private on-prem settings or on devices. We also want open license, so these models can be used in commercial applications. And we want open data. This really kind of gives us a way to think about what's gone into the model. There's transparency associated with it. And this data can then be refined and filtered and processed by the community to develop better models or fit specific applications. And if there's concerns about some data, it can be removed from the data set. And just as importantly, we think the recipe that creates the data should also be open, because this lets us, one, reproduce this model from scratch, but it also gives community the tools to improve the data recipes, create the same model in a different language, and models that sort of fit these 4 pillars can really contribute to monotonic progress, which is what we are looking for. So, a bit detail about RedPajama. On the RedPajama data set, we followed the Llama paper. It has 7 different slices of data. We also carefully followed the process described to filter this data, to transform it, and all of that code is also available with the data set. And we tuned the hyperparameters to select roughly the same number of tokens that Llama paper described they use from different slices. And for the model, we took a trillion tokens from this data set. We used the Pythia architecture, which is one of the most well-documented open architecture, transformer architectures available. And we also instruct tune and chat tune these models to align them to applications. This is really very important because it brings out quality in the latent space of these models. A lot of this was done, in fact, I think all of it was done with open source tools. We used Slurm and Spark for data processing. We used Deeper Speed for pre-training, and Together's Open Chat Kits fine-tuning system for instruct tuning and chat tuning these models. We use the Helm benchmark, which is a comprehensive benchmark around generative capabilities of LLMs, as well as the LM harness model benchmark published by Eleuther, which really focuses more on the log prop side. And the model was built on the Summit supercomputer at Oak Ridge National Labs with a generous grant from the Insight program, and used 3,000 V100 GPUs. And everything that was, from the data to the final model checkpoints to intermediate checkpoints were published on Hugging Face under Apache 2 license. And the model works well. It's one of the more surprising things about this was that we built a 3 billion scale model and a 7 billion scale model in the first run, and the 3 billion scale model is just 6 points behind. The base model is just 6 points behind Llama 7B, and the 3 billion instruct-tune model is just 1 point behind Llama 7B on Helm. And this is fantastic because you can quantize this model further. We've worked with the llama.cpp folks and the MLC folks to bring this to CPUs, and the iPhone. You can download MLC Chat app today to try out the chat version of this model. And it's fantastic because you can use this model in few shot mode to develop applications in contexts where this was just not possible to do before this model existed. And the 7B model is also interesting. A couple of things to note about this. One is that we have made progress over the last generation of open models. It's the base model is 2.4 points ahead of GPT-J, which is an excellent open model from Luther. But you'll also note that open models, including MPT, Falcon, and RedPajama, are lagging behind 3.3 to 4 points behind the Llama model. With instruct tuning, the open models become the RedPajama open model is 2 points ahead of Llama, so it really kind of provides a alternative for few shot applications like sentiment analysis and classification, data extraction. And for these applications, this is probably the best model that exists in open source today. And this is super promising, and we still have a long way to go to get to Llama and to increase the quality of these models beyond Llama. One of the interesting things about open data is that it really lets you do principled analysis on the quality of the model. So one of the things that we spend a lot of time doing is contamination analysis, especially on the instruct data set, because it's a really important part of model quality, and aggressively decontaminate it against the benchmarks in Helm. And this is important because if there's contamination in the data, it can kind of give you a false sense of sort of performance in these models. And this having the open data allows us to do this sort of effort and allows anyone else who's using it and applying it to downstream tasks to verify that the models have the data has been properly decontaminated. But as I said, we still have a lot of work to do, and I want to touch upon some of the avenues for this. A big part of monotonic progress is evaluation. We need to know how well these models are performing. Hugging Face has, for instance, an open LLM leaderboard, which is really fun and evaluates lots of models against a set of benchmarks, which shows Falcon, Llama, and RedPajama are sort of roughly the same on the MMLU benchmark. But a few days ago, there was a technical report from a great set of researchers that tried to reproduce MMLU and found very different results on the right, where the open models are lagging behind Llama. The instruct model does well there. But this discrepancy is really sort of problematic. We want these benchmarks to act as North Stars for model development. And we have to find better ways of doing these evaluations, making sure they're reproducible, they're unbiased, and probably possibly use other strategies like human evaluation, which is, which can be fairly hard to scale. So we need to do a lot of work around this, because once we have effective evaluation methods as a community, we can really sort of drive progress around model development. Another interesting area is data quality. One of the things that we did for RedPajama dataset was to use the mixture description in the Llama paper, and it's pretty clear that if you weight these slices of data differently, you get more quality from the final artifact. And we also likely need to not just weight these these slices, also take sub slices of bigger slices like common crawl and weight those, and have to do this in a sort of principled manner. And there's a lot of value in this. Deduplication is another interesting area. Cerebras just published a data set called Slim Pajama, which is more aggressively deduped version of the data set. It's about half the size. Again, we have to figure out what's the right strategy here, what's the sort of sweet spot for deduplication, and how that interacts with the data mixtures that we design. And then there are problems of data transformation, debiasing data, detoxifying this data. And we think this is really going to be, in many ways, the cornerstone of progress towards better models in over the next few years. And another interesting and problem to solve is that of utilization. As you are scaling out and using a larger number of GPUs to train these models, it becomes a challenge to use all those GPUs effectively. And this graph shows an ideal run on the Summit supercomputer and the real run for RedPajama, and they seem fairly close. But once you get to 3,000 GPU scale, the difference means that 500 GPUs are idle, which is not ideal, and probably represents over a year like a few $1 million worth of computing resources. There's a lot of work happening in this area around communication optimization. Together is particularly focused in this field, and there are open problems of how to take these techniques and apply them into training harnesses, so that you can use them for training different kinds of models without sort of doing custom work for each type of training task. Some of the work that we've done around this is now being used by us for instruct tuning models. It's an algorithm called Cocktail SGD that is able to do training on either over low network conditions in distributed settings, or get really sort of maximum utilization in these high performance computing supercomputer type training setups. And this is a talk in its own right, so I'm not going to dig into details. It's a paper in ICML this year, as well as a source code release that's coming. And as I mentioned, we are now instruct tuning all the models together with this approach, and looking forward to pre-training models with Cocktail SGD soon. So hopefully this gives you a little bit of a window into the process of training these models, how we are using open data sets and open software, and in case of RedPajama, open public infrastructure to build these. But that said, the models that we have today, the artifacts that we have in hand, are very powerful and can be used effectively for real-world applications. There are a few strategies that are particularly effective. One of them is few-shot prompting. This is the most lightweight way to boost model quality, where you provide 1 or 2 examples of your task along with your prompt. The RedPajama 3B and 7B instruct models are specifically optimized for this. And if you want to go further, you can create your own instruct data, start with a base model, and instruct tune that model with your own data. We've seen several examples where people have instruct tuned with their own data and then applied few-shot on top of that to get quality from 3B and 7B models that they can't get from GPT-4. So this is really an effective way to get high quality, high accuracy for your tasks with these models. And you can also, if you have a large amount of data, you can continue to pre-train these starting, and you can mix the original data set, which is an advantage with open data, into your data mixture, so you don't have problems of catastrophic forgetting, etc., and prepare a model that's really kind of designed for your tasks. There are many deployment options now. You can quantize these models further to sort of fit your infrastructure, application, and performance needs. And because the weights are open and the licenses are permissive, this sort of really gives you a lot of different options. And finally, I want to mention that we have taken a lot of the optimization work that we've done and created a AI-specific cloud service, which has thousands of GPUs, has efficient support for inference, model hosting, fine-tuning, training. We're supporting many users in beta today, and if you're focused on building your application, you can use a service like Together's AI Cloud to manage all the production needs. And I'm happy to announce that anyone watching this can go to this link and contact us for early access. That's all I have.
Awesome. Thank you so much. And let's give it a moment and see if anybody has some questions in the chat. Otherwise, what's the best way for people to reach you, follow your work? Is it LinkedIn or Twitter?
Yeah, LinkedIn is great. You can also, send me an email at vipul@together.xyz, and write to us on using the contact form. We store that, and we'll definitely contact anyone who writes there.
Awesome. That's great. Yeah, it's been so interesting to kind of learn about like the proprietary models and the open source models and kind of the different sort of pros and cons that people need to weigh when considering one or the other.
I think the some of the sort of value that we see in open models is around higher ability to customize these models on your own data. There is you can achieve better privacy if you are running them in your own environment or your cloud instance that only you have access to, and no one is able to see that data. You can be assured that your data is private. And also control. This is what's happening with these models are often fairly important in strategic business processes that are being encoded into into prompts, and there's customer data that's going against those prompts. And I think as it becomes a more important part of organizational sort of process, having control of those models will become more important to more people.
Yeah, definitely. And the explainability aspects of it as well, I imagine.
Right. Transparency and explainability are also, I think, important ideas that you can achieve with open better today than you can with closed.
Yeah, that's very cool. That's awesome. Well, thank you so much. And I think we have to cut over to our next and final speaker. But it was awesome having you on today. And all of these talks are being recorded, and we're going to share this with the community. Oh man, okay. Of course, now the questions are streaming in. Great. Quick question, Caesar. He's asking, why do you suggest mixing the data sets? Can't we just fine tune RP with our private data set?
You can, and I think that's the great first thing to try. There are cases if your data set is large, then especially for smaller scale models, you sometimes get this sort of catastrophic forgetting, where they forget some of the things that they've learned from the original data set. So it's a practice that this data mixing practice is often used in this context where you don't want the model to forget what it has learned from the previous data. But it's probably not a concern if it's a few thousand examples, and you can get incredible amount of customization with a few thousand examples.
Yeah, that's great. Caesar, I hope that answered your question. We have another one from Manpreet. He says, these llama-based models don't distribute the final weights, but differential ones. And the repos provide instructions to create the final model weights. What is the rationale behind that pattern? What are the implications on license since the model weights do require the original weights?
Yeah, so the reason people are distributing diffs is that they don't have the rights to distribute the model. The model itself is under a restrictive research only license. And it was also one of the reasons for us to create RedPajama was that it would be a permissively licensed base model that does not have those restrictions, and you could easily release models that are fine-tuned on top of it. So it's really a way of sort of getting around the restrictive license that Llama was under.
Oh, cool. Great question, Manpreet. Glad you brought that up. I'm not going to pronounce this name right, and I apologize. Xinkun is asking, does the AI cloud service work for private data, or should companies with private data host their own open source models?
So we have designed our AI cloud to be, very sort of aggressively private. We think that one of the sort of big benefits of open source models is that you can run them in your private, in your private instances that you control. That said, these models can really run anywhere. They can run in your VPC. They can run on Together's cloud. They could even run on-prem and on devices.
Great. I hope that answers your question. And if you guys have others, maybe find Vipul in the chat or at some of the places that he mentioned earlier. So thank you so much. This was awesome.
Thank you so much. Thanks for having me.
Of course.